Here's problem 4023. Microscopes are inherently limited by the wavelength of the light used. How much smaller in order of magnitude can we see using an electron microscope whose electrons have been accelerated through a potential difference of 50,000 volts than using red light of 500 nanometers? Alright, what is the energy of our electrons? That's going to be equal to the charge times the voltage, 1.6 times 10 to the minus 19 times 50,000 volts, and that is equal to 8 times 10 to the minus 15 joules. So that is the energy of the electrons. Hence the momentum of the electrons is going to be 2 times the mass times the energy square root. And it's going to be 2 times 9.11 times 10 to the minus 31 for the electron mass times the energy we just calculated, 8 times 10 to the minus 15 joules. All this square root. So that is equal to 1.207 times 10 to the minus 22 kilogram meters per second. That's our momentum. Hence, the de Broglie wavelength of the electron is equal to Planck's constant over the momentum, 6.626 times 10 to the minus 34 over 1.207 times 10 to the minus 22, and that is equal to 5.488 times 10 to the minus 12 meters. So that's our de Broglie wavelength. Our resolution for red light would be equal to 1.22 times the wavelength of red light over the diameter of our microscope. Well, the resolution for the electron microscope is going to equal 1.22 times the wavelength for the electrons over the diameter of our microscope. These cancel out, 1.22 cancel out. So this is going to be actually the ratio of the red to the electrons. So our ratio of resolution of red to the resolution of electrons is the wavelength of the red over the wavelength of the electrons, and that is going to be 500 nanometers over 5.488 times 10 to the minus 12, and this is equal to 9.11 times 10 to the 4, or approximately a factor of 10 to the 5. So in other words, the electron microscope can see by a factor of almost 10,000 a smaller resolution than the wavelength of red light. So it's a factor of 100,000 better for the resolution of the electron microscope.